Okay, this is our demonstration for graphing constraints in Excel. We've been working on two variable problems, and your first assignment actually asks you to produce a graph for one of those. So let's do that here. I expect most of you already know how to do this, so obviously this is optional material. But yeah, if you want to see how I would do it, that's what this is for. So just to overview, this is not an Excel class, but because it's a ubiquitous tool, there are a few things that I will try to explain as we go through that I think might be helpful. And graphing is certainly one of those things that Excel gets used for. There's lots of graphing tools. Not many of them are just for graphing lines. And in fact, the line graph that appears in Excel is the wrong thing to use. You could probably engineer a line graph to work, but it would be the wrong thing. That's because we're not technically graphing lines. We're actually picking out coordinate pairs, finding an x and y that go together, and then finding another x and y that go together, and then linking those together with a line segment. So if you sort of walk through here, we're matching up an x value and a y value, 2 points for each constraint. We want to identify and plot those, and those are the points where they intersect with the non-negativity constraint. Okay, so we have in the two variable space we get two non-negativity constraints. That means essentially we're graphing the intercepts, and there's an intercept with both the x-axis and the y-axis. So when you think about your sort of typical algebraic equation written in slope-intercept form, it only has one intercept, but that's because the slope is defined as rise over run, or the change in the vertical over the change in the horizontal. There are in fact two intercepts, of course, one for each axis, and there's nothing that says you couldn't write the equation any way you want to. It's just become a standard. Okay, so in our application, these 2 points that we're identifying on the intercepts, everything in between those are part of our feasible combinations. So when we look at these, remember we look at these one constraint at a time when we're doing analysis and thinking about what combinations could I produce given how much of constraint 1 or resource 1 or how much labor I have available. So when we plot those 2 points on the intercept, because of the linear programming type constraints, we know that everything in between them, those 2 points, is also part of the feasible combinations for that constraint. And so that means that we can join those together with a line segment and have a representation of that partial boundary, right? And so obviously when you take all the constraints into consideration, some parts of the boundary or the entire piece of the boundary may not be part of the true boundary for the problem. It's just part of that partial information that comes from that one constraint. In Excel, the actual name for it'll differ depending on what version of Excel you have, but the keyword for the type of graph we want to use is called scatter. And so some places it's an XY scatter, and in others it's just called a scatter plot or something like that. But what it does is it takes a series of values for the x-axis, and then a separate, or some people refer to that as the abscissa, and then a second one for the ordinate or the y-axis, and then puts them on a Cartesian plane, right? So an xy or abscissa versus ordinate axis. And so that's what we need, right? We need something that recognizes that the x and y values are numerical and that the distance between values matters. So the difference between that and a normal line constraint, we'll look at it, is that a line constraint is just looking for, a line graph in Excel is the intervals are irrelevant on the line graph, right? So you have to mandate that they all come in constant distance for Excel to represent that, and that's not what we want. Okay, so we have 3 constraints. That means we'll be plotting, or if we have 3 constraints, we'll have 3 coordinate pairs. And in the example I'm going to use from the first lab, here we do have 3 constraints. So that I think this is the cheap and premium brew example, and you can see here that I've calculated by dividing the right hand side by some coefficient. The matrix isn't here, but if you went to the spreadsheet where this brew problem was, you would be able to see that that's what's done. So the right hand side of the constraint divided by the coefficient, multiplying C gives you 16.67, 16.67, and then so on as you move down through here. And so then when you get to the points to be graphed, what you actually need is 16.67, the C-intercept needs to be paired up with a 0 for the P column. Okay, and so it's not written here, but this is my C column, and this is my P column. And then so similarly, when you plot the P-intercept, the other variable needs to be 0. And so these are 2 points, and they're the only 2 points that I need for the first line graph. These 2 points I need for the second line graph, and these 2 points I need for the third line graph. So let me open my spreadsheet and we'll look at those steps in Excel. Okay, I have my sheet open here. You can see the same values. You can see that, let me squeeze this down a little bit here. Yeah, you can see that 50 divided by 3 is where you get the 16.67. Right, so this is pretty easy to come up with. And then just let me show you what you get. So if you go to Insert, and then over here is the type, I guess they're called charts, the types of charts that you can do. This is a line chart. And so if you choose a line chart, it tries to predict what data you want. So you want to get rid of whatever it's picking. So remove those two, and then if you click on Add, the telltale that we have the wrong thing here is it's only asking for the values in one series, right? So it's saying give me some numbers like these, and then I'll plot them. And then it just tells you that their interval it's just going to be the first entry, the second entry, and the third entry, and that is not what we want. Right, because that means it's going to make sure that these intervals are evenly spaced, and it's really anticipating that you have something like annual data there, and that eventually you'll replace 1, 2, and 3 with months or years or something like that. So the data should be in some kind of logical series where it's measured at every time. That is not XY coordinate pair information. So let's get rid of that graph, that line graph that we don't want to use. And let's plot the XY scatter or whatever it's called here. So I've got 4 points down here that I want to use. I want to click over here and then go to Insert. And then this is what the scatter looks like. So it says scatter and then comma XY. And it looks like there's another type called a bubble in there, but we don't want that one. So this is the scatter without the lines connecting, and this is the scatter with straight lines connecting. And so I'm going to click on that type. And you can see, because I chose a blank area of the sheet and didn't have the cursor wasn't around any data, it didn't try to predict for me what kind of graph I was going to build. But I know what kind of graph I want, and I know the points are right down here. So I right click here, and then you just click Select Data, and then you go Add, and then for Series 1 I'm just going to type B1. That's my first constraint. And then for the X values, I'll need these two, right? So these are the C values, 16.67 and 0. And then you need a set of Y values that pair up with those, and that'll be these two. Click that. Now you see I have a line between 16 and 2/3 and 16 and 2/3. Click on OK, and then to get the second constraint on here, we just click Add. And we're going to do a new series, and I'll call it B2. It's my second constraint, or my second boundary piece. I don't know if it's going to be on the actual boundary or not. And now we'll just grab the 20, we'll go down to B2.1, B2.2, get the X values or the C values, and then get the P, right, the premium, and we get our second constraint. And with that, I think it's obvious how we would add the third one. We just go to Add and add the third one, but I'm not going to bother with it. I will just open this up a little bit, and spread it out and maybe even encourage you that it's pretty easy to make the font changes and the formatting that you would want to make that easier to read. But the important piece I still haven't done yet, and that is to make it obvious to the viewer of my graph what is on the x-axis and what is on the y-axis. And so I could do that by going up here to the design label, be sure that is clicked, and then all the way to the left it'll say add chart element. So I click on the add chart element, and it has a area here for axis titles. Go to primary horizontal, and it'll add an axis title for you. And then I could just put cheap brew quantity or something like that, or I don't care, just C or whatever, just something that makes it clear what is on which axis. Okay, and then to get the other axis up here, you would go axis titles vertical, and then premium brew quantity. Oops, there. And then again, just make it readable, even if that isn't spelled correctly. It's a little strange to be typing vertically like that, but there it is, premium brew quantity. And that's a graph that now I could look at, and I know you could add, I guess, one more thing. Let's just go back to add chart element, and down here it says legends, and so we could add it to the right or the bottom is usually where I put those. And then again, I want to format the font to something that's a little bigger so I can see it. I know the orange line now is the second constraint, the blue line is the first constraint. They're both less than or equal to constraints, so it's really about being on the inside of this. And I'm not interested in you trying to clean this up any further. Now obviously you could solve for where the orange and the blue line cross, find that exact point, and instead of plotting your orange line to go between this axis and this axis, you could plot the orange line so that it goes from here to here, and then the blue line only goes from here to here, and you'd have a perfectly joined up feasible space. It's just not that important, right? We can always indicate which side of these are feasible. You could just use something as simple if you wanted to do something to make it clear what you're working on, what is going on your graph. You would just do something like add a text box, and then you would just type something like feasible space. And you could even put a note, interior to both orange and blue. I don't really care too much about that, right? Because you have to write a paragraph. I think you have to provide a paragraph, right, that explains your solution. But anyway, that's fine. So something like that. Don't get too involved in learning to prepare these graphs. I mean, do as much as you want to learn the technique, but for the presentation I'm mostly looking for, have you adequately depicted the constraints? Are you able to work with feasible space, and did you take the time to label things so that I can tell what is what? With that, I'm going to shut this tutorial down and hope it helps somebody.